Hello everyone, my name is Shikhar Sinha and I'm here to present a presentation on the topic linked list and list in C programming language. Linked list is a very essential topic when we are studying data structures or in embedded system or in software development field. This is a really important topic. Linked list and list in C, exploring the core concepts and practical applications of linked list in data structures. Introduction to list. Linear order. Sequence of elements arranged linearly. Implementations. Static or dynamic. Node structure. Each element is a node with data and links. Why linked list? Arrays have a fixed size with a predefined length, which means that memory must be allocated in advance. This can lead to inefficient use of memory if the allocated space is not fully used, resulting in wasted resources. Accessing elements in the array is very fast due to contiguous memory allocation, which allows for direct indexing. However, resizing or inserting elements requires shifting many elements, making these operations costly in terms of time complexity. Arrays are best used when the number of elements is known in advance and random access is a priority. Linked list. Linked lists use dynamic memory allocations, meaning nodes are created as needed, allowing the list to grow and shrink in size efficiently. Each node contains data and a pointer to the next node, which enables easy insertion and deletion of elements without the need to shift other elements, unlike arrays. This pointer-based structure allows flexible memory use and easy reordering of elements, making linked lists ideal for applications where the size of the data set changes frequently. However, accessing elements sequentially means that linked lists generally have slower random access compared to arrays. So in general this is the difference why we use linked lists more in comparison to arrays when even arrays exist. Structure of a linked list. So in linked list is a node and a pointer which point to the next node. In C structure, this we use structure class to define the linked list. In structure class there is a data pointer and there is a next pointer which point to the next node. A dynamic allocation, we can also allocate dynamically linked list. So we use the keyword malloc to dynamically allocate a linked list variable. Chain formation, nodes are linked to form a chain. Memory representation of linked list. Singly linked list. In singly linked list, the one node points to the next node and that next node points to the other next node. But in doubly linked list, there is a pointer previous and to the next of a node itself. And in circular linked list, there is a circular fashion of linked node pointing to each other. The last node points back to the first node itself. That's why it is a circular linked list. And doubly linked list is a really important topic because there is a two pointer which one point backward and other point to the next element, which can be really useful in many algorithms. Types of linked list. Singly linked list. Nodes link only to the next node, forming a unidirectional chain. Doubly linked list. Nodes have pointers to both the next and previous nodes, allowing two-way traversal. Circular linked list. Last nodes point back to the first, creating a circular loop of nodes. Header linked list has a special header node that stores metadata about the list and links to other nodes. So these are the types of linked list. And in singly linked list, the one node points to the other node. In doubly linked list, there is a two-way of nodes pointing to each other. In circular linked list, the node points back to the first. Operations on linked list. So we can perform many operations on linked list like insertion, deletion, concatenation I, we can join two linked list. Then we can also do traversal on linked list I. We can display all the elements of the linked list, or we can access element of the linked list. We can also reverse the node order of the linked list, and we can also search an element inside the linked list. So these are the operations on the linked list. Key operations, key value, using key value pair nodes. So in this program we will see the main operations of the linked list. So here we are creating a structure class in which a node is defined. A node contains a key and the data, what the value it stores, and the next pointer which point to the next element of the linked list. So here we are creating a head of the linked list. Head is the first element of the linked list. Void insert end key in data. So here this method is used to insert an element inside the linked list at any position. So here we are creating firstly we are creating a node itself using malloc keyword, and then we are using a key and a link variable to know. Here we are using a key variable, so we know where we need to insert the element inside the linked list, and using this key we insert inside the linked list the node itself, the display. And in this method we display all the elements of the linked list. So firstly we use a ptr variable which stores the head of the linked list, and then we traverse all the elements of the linked list, and then we display each element in this line. And this is a function which see if the linked list is empty or not. If head is pointing to the null variable, then the linked list is obviously empty, so it returns true. So if the linked list is empty, then returns true. Then there is a search function. In search function we give a key value. In key value, if like we give 5, so if it search inside the linked list if that variable is there or not. So firstly we use a pointer variable current which stores the head pointer, and then we traverse across the linked list to see if that element is there or not. If the element is there, then we return that. And this next is a delete function. This delete function is used to delete a key from the linked list. This deletes the element from the linked list. So here we use two pointers, one current and one previous, and that when we get that element inside the linked list, so then we use this previous pointer to point to the current pointer. So in this way that key gets removed from the linked list. Next is a reverse function. In reverse function we use one previous, one current and one next pointer. Here we use 3 pointers, and then we traverse throughout the linked list, and using this next current and previous pointer we reverse the linked list using this algorithm. Then this is a main function. Here we are inserting firstly 10, 20, 30, 40, 50, 60 inside the linked list, and then we are displaying it. So after displaying the linked list will look like this. Then we are using a found keyword in which we are searching if 3 is there inside if at the 3 position what the number is there inside the linked list. So after performing this, we found that if at key 3 position we found that data is 30. Next we are deleting the 4th position element inside the linked list. So after deleting that key 4 with data 40, that 40 value gets deleted from the linked list. So after that value is deleted, we are displaying the list again here. So after displaying that list, then here that 40 variable is not there, and then we are reversing the linked list here, and after reversing the list we are again displaying that element. So after displaying that element, look after the last element comes to the front. So in this way this program is executed. Next is arrays versus linked list. Next is time complexity comparison. So in singly linked, so this is table is in this first column is for singly linked list, second column is for doubly linked list, and third column is for circular linked list. So in singly linked list, insertion at the front is the time complexity is big of 1, and insertion at rear end is big of n. Deletion at front end is big of 1. Deletion at rear end is big of n. Searching element cost big of n, and traversing the linked list costs big of n. But in doubly linked list, it in insertion at the rear costs only big of 1, because there is 2 pointer. Because of the 2 points it costs big of 1, and in the same way deletion at rear also costs big of 1 here. In circular linked list, insertion at the rear costs only big of 1, because the last element points back to the first element. So this is the time complexity comparison of singly linked list, doubly linked list, and circular linked list. Next is real world applications of linked list. So linked list is used in stacking queues for dynamic data structures, polynomials to represent terms, task scheduling, round robin scheduling, graph entries, node with multiple links. Linked list is also used in memory management, in OS and compilers, and linked list is also used in undo and redo tracking actions also. Next is advantages of linked list. Dynamic memory allocated as needed at runtime, efficient operations, fast insert, delete, especially at ends. Better memory use prevents unused array space. Flexible structure grows strings easily, useful for stacks and queues. So these are the advantages of linked list. Because of these advantages, linked list is heavily used in many data structures and many algorithms as well. Disadvantages of linked list: memory overhead, additional memory for pointers. So because of the pointers, sometimes it is not preferred, and because of this, sometimes we use arrays as well in place of linked list. Sequential access, no random access must traverse. So if we want to get a node inside a linked list, then we need to traverse from the first element I from the head. But in case of array, we can directly find that element inside the linked list in the array. But in linked list, we need to traverse from the start. Pointer complexity, increase bugs, segmentation faults. So in linked list, there is many times segmentation fault can occur. That's why many programmers don't use linked list. Slower searches, big O of n time versus big O of n in arrays. So in linked list, for searching, big O of n time is used, but in arrays big O of 1 is used, which I explained before. In conclusion, linked list is a flexible, memory efficient data structure that adapts to dynamic programming requirements. Idea for managing dynamic memory allocation, where size and structure can change during runtime. Strengthen programming fundamentals and pointers management skills through hands-on practice. Core to building more complex data structures, stacks, queues, and graphs. Understanding linked list is essential for efficient resource management and solving real-world computing problems. Thank you, and that's all from the linked list topic.